Hey there, Patriots. In this video, I am going to tell you what a dilation is and what directed line segments are. So a dilation is the enlargement or reduction of a pre-image to an image. The pre-image and the image are always going to be similar because the side lengths will change and my angles stay congruent. So my sides are going to be in proportion and my angles are going to be congruent. So right here, if we start with triangle ABC, here is my pre-image. Let me get a pen. There we go. Here is my pre-image. A prime, B prime, C prime. Remember the primes. Those are the image. So this would be a dilation. Notice it's not a rigid transformation because the size changes. The sides are not the same. AB is not congruent to A prime, B prime. So segment AB is not congruent to A prime, B prime. As we can see, ABC is smaller than A prime, B prime, C prime. A prime, B prime, C prime is actually bigger. So this is what we call an enlargement. This is an enlargement. ABC got bigger to become A prime, B prime, C prime. Here we have XWZ. This is my pre-image because it doesn't have apostrophes. X prime, Y prime, Z prime. This is my image because of the apostrophes. So again, this is a dilation. This not rigid because the sides are not the same. And so this is a reduction. Please notice triangle XYZ is similar to triangle X prime, Y prime, Z prime. They're similar. They're not congruent. The angles are the same, but the sides are in proportion. I should actually go back to this one and I can make a note of that as well. Triangle ABC is similar to triangle A prime, B prime, C prime. My sides are in proportion, and my angles are congruent. Now the center of a dilation is going to be some fixed point. And we're going to move away from that point. So my corresponding distances are going to be in proportion. So what I'm saying is if we are in proportion, C to X, C to X prime, C to Y, all the way out CY prime, C to Z, C to Z prime. So all three of these are going to be the same. They're not the same, I'm sorry, but they are going to be in proportion. So when I'm looking at this, if we start with our dilations, we like to put the image on top, pre-image on bottom, image on top, pre-image on bottom, image on top, pre-image on bottom when we are dealing with dilations. So then what we'll have is the distance from CX prime to CX. CY prime, the distance to CY. CZ prime, CZ. So C is the center. C does not move. But from C to X and C to X prime, that's how, because here we have my image in red. I'm sorry, in red we have the pre-image, and in blue we have our image. And I know it's the image because of the primes. Okay, and when we're writing dilations, we always like to do image. If we're doing a dilation, I want you to do an image over pre-image. It will make other steps easier if you do it this way. This is why I always want to do image over pre-image, is because of my scale factor. A scale factor is some constant value. It's a number that we multiply the pre-image by to find the lengths of the images. And K will mean scale factor. So what this means, if I take my pre-image length, if we do, did I make it green last time? Look, I want to keep my colors consistent, so I'm looking back. Yeah, start with green. So if my pre-image is green and my image is blue, how I can make an equation is if I take K and I multiply it by CX, that's going to give me the length of CX prime. So my scale factor times the pre-image equals the image. So neat little fact. So K times the length of my pre-image equals the image. So to find scale factor, so we can write this equation differently. To find K, you would just do the length of blue over the length of green. And it's any blue over any corresponding green. Okay? Well, what if I just give you points? Given our points and I want to find K, I can do corresponding X's or corresponding Y's. So if we put some colors up here, there's my pre-image, image. So again, image over pre-image will give me K every time. And K times pre-image gives me image. Okay? You're just going to pick one. Either do purple over green or orange over blue. You don't need both. Just pick one. And then we have what we call directed line segments. So a directed line segment is a dilation where one end of my segment is going to be the center. So if we're going from A to B, what this is saying is from A to B means A is the center. So start at A, go to B. We're going to go that way. A is going to be the center of my dilation. If we're going from B to A, that means B is the center. B stays put. And we start at B and we go that way. All right? So the center, wherever I'm starting from, is the one that's not going to move. We're going to move B closer to A or A closer to B, depending on which one's the center. Start at B, go to A. Okay? So in general, you're going to tell me what is the center of this dilation right here, which of the points is the center. Is the dilation an enlargement or a reduction? Let's complete that proportion. And then write the scale factor using segment QS. So how would you write a segment? I showed you that so flip back in your notes, find it, and go from there. If you have any questions, let us know. We're glad to help you out.